Let's take a look at the following example. In this value signaling example, if we take a look, we see that we have an event structure contained within a while loop. If we run the VI, we see that whenever we type a value into the string that's not empty, the valid indicator says true. When we click to clear the string is set to be empty and the valid is set to be false. Let's examine the code quickly. We have several cases in the event structure. In the stop case, the loop is stopped. In the string value change case, a simple comparison is performed. If the string is not empty, the valid is set to be true. Next, let's examine the clear event case. In this case, it's a value change event on the clear button, and inside this case, we're setting the value signaling property of the string control to be empty. Take note that in this case, we are not setting the valid indicator. However, if we set a value in the string, and then we choose to clear it, the valid is automatically set to be false. Let's observe what's going on by activating the execution highlighting. First, let's run this again. We'll put a value into the string control, observe that valid is true, and now let's activate the execution highlighting. This time when we push clear, we can observe we first go to the clear value change case, where an empty string is placed into the value signaling property of the string control, and then observe that the event structure fires again, this time with a string value change event. That is how the valid indicator is being updated. What's happening here is that the value change property being set in the clear case is not just setting the value, it's also emulating a user interface event, and that's why the event structure fires. This is a very useful feature. We can use this to simplify and modularize our code. This is a good example where we had certain code inside our string value change event which we wanted to use. We didn't want to have to recreate the check of the string validity inside of our clear case. So by simply using the value signaling event, we can ensure that whatever code we've written inside the string value change event will fire. One important note to keep in mind when using the value signaling event is that it can be used on any type of control, including Booleans. However, remember, when we use a latch mechanical action of Booleans, it's not valid to have local variables, nor is it valid to have value properties used. So if we have a Boolean control and we're trying to write to the value signaling property, we will get an error unless the mechanical action is set to switch. The next additional topic to discuss is the first call function. The first call function is available from the synchronization palette right here. It's a simple function which returns a true or false value. It has no inputs. What it returns is whether or not that particular instance is the first time that this part of the code has been called. Let's proceed with an example. Let's create a while loop with a stop control. We'll put a short delay inside. In this case, 2 seconds. Let's put an indicator on our first call. Let's also create an indicator on our loop counter. This time when we run it, we'll observe the loop iteration and the value of the first call function. We see the first time through, the first call is true, and then in all subsequent calls, the value is false. This is a very useful function, and it can actually be used in functional globals. For example, if this was an uninitialized shift register, we can avoid having to explicitly initialize things by using the first call as our input to our case structure. Recall that functional globals have uninitialized shift registers plus case structures to determine how to behave in different situations. Here, if the first call is true, this is the initialization stage. This is where we could, for example, put a number, such as a random number, into our shift register. In all subsequent calls, we could perform a different action, such as perhaps incrementing that number by 1. If we were to create an indicator here and save this as a sub-VI, we'd see that we'd have the same basic functionality as we've seen with the previous functional global examples, However, in this case, we do not need to explicitly initialize it the first time that it's run. The next additional topic to discuss is variant data. Variant functions are available from the cluster, class, and variant palette, here under the variant section. If we pin this down, there are two functions that we fundamentally need to use. One is variant to data, and the second is to variant. Essentially, a variant is a way to store any type of data across a single wire. Let's proceed with an example. Let's create a Boolean control on our front panel. We'll call this the type select. And let's create a numeric control and a string control. Next, on our block diagram, let's create a case structure. We're going to take the type select as the input to our case structure. And in the true case, we're going to take the numeric control and use the toVariant function to convert that numeric control to a variant. Next, we're going to connect that variant out through a tunnel and right-click and create an indicator. If we look at the front panel now, we see we have this variant data type. We can also access the control and indicator types of variants via the controls palette by right-clicking, choosing variant and class, and then choosing a variant object. If we return to our block diagram now, in the false case, we're going to connect the string again through the cluster, class, and variant palette, variant subpalette, a toVariant function. We're going to convert the string also to a variant, and this time connect them together. Now, just remove this function so that we can run the VI. If we put some values in here, for example 999.9, and this is my string, if we run this now with the type select as false, we see that the variant contains, quote, "this is my string." If we set the type select to be true, we see that the variant contains the number. What's happening here is a bit of a subtle point, and you may question what the purpose of this is. Well, we're going to see in the example at the end of this section the power of using the variant data type to be able to send data of different types along the same type of wire. It turns out that any type of data, numeric, string, Boolean, arrays, clusters of arrays, and so on, can be converted to and from variant data. To go in the reverse direction, we could create another case structure. We're going to wire the same type select control in, and this time instead of toVariant, we're going to go back to the palette, variant subpalette, and choose variant to data. In this way, we're going to go back from our variant type to our original data type. So here we connect the variant as the input. Just put this up to the side, clean up our wires a little bit. And in the true case, as we saw here, we're going to convert back from our variant to a numeric type. So let's make a duplicate of each of these, change them both to be indicators, and call them numeric out and string out. And what we want to do in this case is if the value is true in the type select, we want to convert back from our variant into a numeric. What we see is when we connect the data output to our numeric indicator, it automatically inherits the proper type, and as a result, will convert the data properly. Let's remove the empty cases and then duplicate this case. Now, in the false case, what we want to do is connect our string out. This time, the data will automatically be chosen to be a string. So if we return to our front panel and we run it, let's reinitialize our values to default first, put in some different values, and run. We see when the case is false, we get the string out properly. And when the case is true, we get the number back.